So in this video, we're going to be taking a look at our last section of notes, which is 1.4 pairs of angles. So we're going to be looking at special relationships that happen when you have two angles next to each other, or not necessarily next to each other, but just a pair of angles, so two or more angles. So some pairs of angles are special because of how they are positioned in relation to each other. So our first angle relationship here it is called adjacent angles. So adjacent, think like the house adjacent to yours, right? It's next door. So adjacent angles are two angles that lie in the same plane and have a common vertex and side, but no common interior points. So if you take a look at this first picture here down below, we have angle 1 and angle 2. This would be an example of adjacent angles because they share a vertex right here and they share a side. So this ray that kind of goes between them, right? They share that side and they share a vertex that makes them adjacent. If you look at this second one here, this is also technically a pair of adjacent angles, angles 1 and 2. Again, they have that common vertex here, that's this point, and then they share a side, which would be this little segment right there. So those are adjacent. But if you look at this third picture here, these two angles, if we looked at angle 3, which is this angle here, and it's not labeled, so let's put a little 4 in it. We'll call this angle 4. So this angle here, these are not adjacent. They do not have the same vertex, right? They do not share a side. These would not be adjacent. So let's write down next to that, not adjacent. Okay, but these two other pictures would work. So our next vocab word is linear pair. A linear pair is a pair of adjacent angles with non-common sides that are opposite rays. So if you look at this first picture here, this is a linear pair. This is always what it's going to look like. Maybe sometimes it's upside down or sideways or something like that. But this is in general our shape that you want to look for. So linear pair, if you dissect this phrase, linear line pair 2, it's basically two angles that are going to form a straight line. And if you look at our first picture here, down along this bottom, there is a straight line. So just so to make sure you guys can identify these properly, remember it's adjacent. So that means we're going to share a vertex here, which 1 and 2 share a vertex. They're also going to share a side, which would be this right here. And then their non-common sides, or in other words, the side that's not that shared side that I highlighted in yellow, we're going to have opposite rays, which if you take a look, these two rays down here are definitely opposite. They're going in opposite directions and they share an endpoint. So this is a linear pair. Something else I want to point out, linear line, right? Lines are 180 degrees. Remember last section, we learned about our straight angles. Down here, this forms a straight angle. So something to mention, and I would definitely write this down because it's important, linear pairs are always going to have a sum of 180 degrees. So for example, if angle 1 was 120 degrees, angle 2 would have to be 60 degrees. So the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. These are always going to have that. If you look at this next picture, this is not a linear pair because here, these are definitely not opposite rays. So that would not work. There's no way that would have a sum of 180 either. So maybe take a note here and write not a linear pair. Okay. Next vocab word is vertical angles. We're going to end up seeing these a lot. Vertical angles are two non-adjacent angles formed by two intersecting lines. Now, what this looks like, since it's formed by two intersecting lines, vertical angles are kind of always have an X shape. Like if you look at this first picture here, one line intersected with the other line, you have this X shape. So if you look for your X shape, you're going to have vertical angles. Where if you look at this next picture, it's like someone tried to make an X, but it got a little lopsided up here, right? This line from D to E to B, that's not perfectly straight. So this would not be a vertical angle, right? Two straight lines intersecting, this is not a straight line. So let's go ahead and say this is not a vertical angle. Okay, but if you look at this first one, this is. Now, vertical angles are going to have a few special properties. So first, let's just identify, well, which ones are vertical? Well, it says here that they're non-adjacent. That means they're not next to each other. 1 and 4 are next to each other, so that wouldn't work. 1 and 3 are next to each other, that doesn't work. 3 and 2 are next to each other, that doesn't work. All right, so we're actually looking for the ones on the opposite sides of the X here. Okay, or another way you can kind of think of it as like V for vertical. Right here you have a little V shape. Right, so you can highlight that here. You have a little V shape, and there's another little V shape opposite it. That's what forms your X. So it's actually the ones opposite each other. So angle 1 with angle 2, that would be a pair of vertical angles. So let's write that down. Angle 1 and angle 2, that's one pair. And then 3 and 4 would also be a pair. So 3 and 4 would also work. That's supposed to be an and, it's just really sloppy. Getting used to a new stylus, and I don't know how I feel about it yet. We'll pretend like that's an and symbol. One other thing, vertical angles are always, always, always congruent. If you took this X shape and folded it in half vertically, right, this way, 3 would line up perfectly with 4. If you cut it in half horizontally or folded it in half horizontally, 1 would line up perfectly with 2. So those angles that are opposite each other here that are vertical are going to be congruent. So for example, let's say I told you angle 1 was, I don't know, how about 150 degrees? That means angle 2 is also 150 degrees. And in fact, you could use that to find 3 and 4. If you look at just angle 1 with angle 4, does that look a lot like our picture up here with our linear pair? That's because it is. This picture has both vertical angles and linear pairs. So if angle 1 is 150 degrees, angle 4 would have to be 30 degrees because that would have a sum of 180. So that would be 30 degrees, and this would be 30 degrees. So just a few other things to think about there. Supplementary angles, you've probably heard this word before. Those are two angles with measures that have a sum of 180 degrees. Now, we've already talked about a kind of angle that adds to be 180 up here with linear pairs, right? Linear line being 180. Linear pairs are always going to be supplementary because they always add to be 180 degrees. So linear pairs are just a special type of supplementary angle. So linear pairs are always supplementary. So if you take a look at this first diagram here with angles 3 and 4, That's just another example of a linear pair. You can tell because we have our opposite rays on the bottom. So, for example, if I told you that angle 3 was 20 degrees, well, 180 minus 20 means angle 4 has to be 160 degrees. They have to add to be 180. And if you look at this diagram here, angle P and angle Q, they're not connected, but if you took 60 plus 120, it's still going to give you 180. So those are also supplementary, even though they're not connected. That's okay. They just have to add to be 180. So any two angles, if you take one angle plus another angle, it equals 180. That makes it supplementary. A similar vocab word, again, you've probably heard of it before, is complementary. These are two angles with measures that have a sum of 90 degrees. So again, these two diagrams are both complementary angles. It doesn't matter if they're attached or not. They don't have to be adjacent. If you take a look at this first picture here with angles 1 and 2, you might notice this little box. That's our right angle box, which automatically tells us that this entire angle is a right angle, which is 90 degrees. So angle 1 and angle 2 would have to add to be 90. So again, we just kind of make up a measurement here just to help show this. So let's say I told you angle 1 was 60 degrees. That means angle 2 has to be 30 degrees, right? Because that's going to add to be 90. And then if you take a look at these, 65, right, plus 25 is also going to give you 90 degrees. So angle A and angle B would be complementary as well. So again, any two angles that add to be 90 degrees are going to be complementary. And then our last vocab word for the day is perpendicular. This might also be a word that you've heard in algebra. You had to write the equations of perpendicular lines. Now we're just going to kind of focus on the properties of perpendicular lines. We'll get to writing equations eventually. But perpendicular lines, those are lines, segments, or rays that form right angles. Okay, so if they form right angles, they are perpendicular. So this picture here on the right shows line AD and line BC. They're intersecting. And then you have your little right angle box here. So that means they're forming right angles, which means they are perpendicular. So there's a few things you need to know. First of all, there is a special symbol for perpendicular, and it looks like an upside down T. So if you see a little upside down T, this means perpendicular to. That's how you would read that. So if I wanted to say line AD is perpendicular to line BC, it would look like this. You would put your line AD with your double-sided arrow, put your upside down T for perpendicular to, and then line CB. Again, with your two-sided arrow. So that, if you were to read that, that would say line AD is perpendicular to line BC. And we know that because we have our right angle box. So a few things, perpendicular lines intersect to form 4 right angles. If this angle here is a right angle, then this angle here is a right angle. They would all have to be right angles. The reason that happens is, number one, this goes all the way around, so everybody has to add to be 360 altogether. And here you also have some linear pairs, so if one side's 90, the other side's 90. And then perpendicular lines intersect to form 4 congruent adjacent angles, right? Because they all happen to be 90, plus they all happen to share a vertex and a side. And then the right angle symbol indicates lines are perpendicular. So if you see a right angle box, that tells you they are perpendicular. right? They form right angles. Right, and then in the next video, we'll get into some examples.